Hi all of you. Welcome to another lecture of antenna and wave propagation. These are the topics in module 6 of KTU syllabus. Myself Maria Joseph, Assistant Professor in EC Department of MBC CT Pyramid leading the session. We have the space wave propagation, LOS and duct wave propagations are the topic for discussion today. First one, what is space wave propagation? In the last class, we have already seen what is a space wave propagation. In this session, we will learn how to find the line of sight. Space wave propagation is practically limited to line of sight distance. That is, it is a type of propagation which is limited to a line of sight distance, and it's also limited by the curvature of Earth. Okay, it depends on the way in which the curvature of the Earth is built. What is LOS or line of sight distance? It is the distance between a transmitter and receiver in which if a direct ray passes from the transmitter to the receiver without being intercepted by the bulge in the Earth's surface, considering the variation of refractive index of Earth's atmosphere with height, the transmitting antenna must see at least the top of the receiving antenna. That is, it is actually the distance between the transmitter and receiver. If a direct ray passes from the transmitter to receiver without any bulge, then the transmitting antenna should be able to see the receiving antenna. Such a type of propagation is called space wave propagation. That is, if you transmit a signal from here, then you have to receive without considering the any other factors. The ray should reach at least the top of the receiver. Line of sight is possible only up to a sight distance, and this distance is determined mainly by the heights of the transmitting and receiving antennas. Let us see how to find the range of space wave propagation, or up to how much distance the space wave propagation is possible. Suppose that this distance is d. Okay, this distance is d, that is AC distance is d. Let d be the distance between the transmitter and receiver, and the heights of antenna are given by ht and hr respectively above the ground. Now from the figure, we know that d is equal to d1 plus d2. That is, almost this distance will be equal to this distance. That is what we are considering. d1 plus d2 is equal to d. Fine. If r be the radius of the Earth, that is, we know the value of radius of Earth is nearly 6,000 kilometers, exactly 6,370 kilometers. Then from the triangles ABO, and we have CBO. Fine. So we have two triangles, and what we know, how can we find d1? d1 is equal to root of ht plus r, that is ht plus r, that is this. Okay, root of ht plus r minus r square. Why? We consider this as a right triangle, and we find d1, this value as, how are we finding? d1 is equal to this distance, d1 is equal to the root of ht plus r minus r square. Similarly, you can find d2 also. If suppose d2 is this distance, then you can find the distance BC also. Okay, that is d2 is equal to root of ht plus, hr plus r the whole square minus r square, because this is also a right triangle. You can find CB. Understood? That is by using the Pythagoras theorem. Hypotenuse square is equal to the sides squares. So you expand the equation ht square plus r square plus 2ht r minus r square, and you can it is almost equal to root of 2r ht, neglecting the heights and the distance. Fine. Height of the antenna is neglected in with respect to the distance, so you get this almost equal to 2r ht, and this, putting these values, you have d is equal to root of 2r ht plus root of 2r hr. Then you substitute the value of r, 6370 kilometers. You get the value d is equal to 3.57 into root of ht plus root of hr. kilometers, where HT and HR are respectively the heights of the antennas. If we determine the height of the antennas, then we can determine the value D. This is a very simple derivation, but a frequently asked question for university examination. So you have to learn this derivation. It is simple. Fine. The next small topic is the duct propagation, that is temperature inversion, or we say it is troposphere ducting. Certain weather conditions produce a layer of air in the troposphere that will be at a higher temperature than the layers of above and below it. Such a layer will provide a duct creating a path through warmer layer of earth which has less loss than cooler layers above and below. So in between, if there is a layer formed due to certain weather conditions, then we can make the signal to pass in between them, and that type of propagation is called duct propagation. That is, layers are formed by the temperature inversions and they can form a duct, so that the red one will show you this will be the duct region, the color in blue color. The upper one will give you the warmer air, so that the signal will flow. I mean, the electromagnetic wave can propagate between the layers. Typical line of sight communication. Actually, duct propagation means it is like a leaky waveguide. I think this figure is clear. Warm air is there, you have cool air here, then you make it to flow along this path by within. For example, I think this you can relate this best to a total internal reflection. That is, you make itself to flow within that area itself. Understood? The applications of spaceways or radar communication is there, microwave linking, mobile systems, and satellite systems. If you need further look on to these topics, I think better you can go on Google, you can search it, or antenna and wave propagation of KD Prasad is the best text to study this topics. Fine.